discussing about the electric field, that is magnetic field, as well as its derivation. Coulombs law. How many of you remember the Coulombs law? Gauss law. Can anybody state the Coulombs law? All of it. Stand up or raise your hand and tell me. Coulombs law states
Q1 Q2 by 4 by epsilon.
what is the main factor in division?
R square.
R square. So how will we be stating that? That is
Force.
Coulombs law denotes what? Force. Okay, so here we will be studying about the Coulombs law and its derivation, and with the base of the Coulombs law we will be deriving the force due to a point charge, due to a line charge, and due to a surface charge. Okay, so after deriving this we will be going for the Gauss law. So what purpose we are going for Gauss law? What is the main thing in Gauss law? Closed surface. Okay, so Gauss law is to, if the surface is closed, so we will be seeing is closed integral law. Okay, so which means the surface is enclosed. Okay, so that the surface will contain some charges. That charge will be denoting it as enclosed. That is, we will be in charge. If we are saying that in charge means we will be denoting it as Q. So we will be saying that Q enclosed. So overall the unit we will be deriving this. For these derivation, for Coulombs law and for Gauss law, what is the basic? What are the two quantities? The physical quantity to be determined. What are the two quantities? Two quantities. Scalar quantity and vector quantities. For a physical or a fundamental state to be defined, we have to define it in the term of scalar quantity and vector quantity. So what is called scalar quantity then? So scalar, we all know that. Okay. Scalar quantity will represent only the physical quantity that has only the magnitude. Okay. So for defining the scalar quantity, it will have the physical quantity will have only the magnitude. Then the quantity is said to be what? Scalar quantity. Okay. So what about the vector quantity?
It has both magnitude and direction.
So if the physical quantity or fundamental quantity, it has both the magnitude as well as the direction. So then it is going to be both the magnitude as well as the direction. Then it is said to be vector quantity. So you will remember that vector algebra. Okay. So what is three algebra means? What are mathematical algebraic solution? We will have to do with addition, subtraction, and multiplication. The same thing we have to follow for the vector first. Okay. So if you are taking 2 points, a point A and I am taking a point B. Okay. So a point A having a charge of, I am saying a point A having a charge of Q1 and the point B having a charge of Q2. Okay, these 2 points are separated by a distance r. Okay, this is the basic for Coulombs law. Okay, so when I am saying this, the 2 point charges separated by distance r. So separated by a distance r. When I am saying one of the compound, I will be saying its magnitude as well as with what direction the charge is moving. So 2 quantities or 2 things are coming in factors. One is magnitude, that is the magnitude of the A. If it is I am saying that A is a compound, right? We can say that A is a conductor. Okay, any current carrying conductor. Okay, so you might have studied physics also. Any current carrying conductor. Okay, what structure is it? Is this? 2 current carrying conductors separated by distance capacitor. That's it. Okay, so that is the basics of this. All the for every electronic, as I said in the first class introduction, for every electronic devices, the base thing you have to just know about from the electromagnetic field theory. Okay, so here we will be saying that conductor A. So conductor A means it will be having some prescribed value. That is the magnitude of it. Okay, and that has a charge flowing in it, right? That charge, when I am saying flowing, it comes under the vector quantity. Okay. So how many of you remember that unit vector? Unit vector r cap, right? Why we are saying that is here r cap? Why shouldn't we say as n cap? So here the distance is separated with the letter r. Okay, for n number of times. I am saying that here I have considered the two charges q1, q2. Okay, so it will experience as a force. Likewise, the conductor B will experience as a force. Okay, so I am taking this force as 1 and this force as 2. Okay, both are separated by the distance r. So when we are saying the unit vector, we will be saying that r cap. Okay, if I am taking n number of conductors, okay, I am taking n number of conductors, the distance will be also n number. Under that condition, we will be saying that as n cap. Okay, if the distance is prescribed or if the distance is known with a letter r, means you should define the unit vector as r cap. Okay, so if the distance or vectors are defined in some other letter, we should define in that particular cap. If it is I vector, means we will be mentioning it as I cap. That's it. Okay, so that is how unit vector stands. So how many of you remember this coordinate? Okay, how many of you remember this? Any clockwise direction or any? Maybe this will be clear for you. What is this? Now do you remember this? What is this? XYZ. What is the name of it? Cartesian. In my maths also you have studied this. Okay, so we will be taking this as x, y, z. No issues if this is taken as x. The maths we have seen that here it is taken as x, y, z. If you look at your physics or field theory, you will be taking this as x. Okay, no issues in it. Anyway, it is going to be like this. Okay, so through x we will be taking this as I, and here for y, j for z, k. This is rotating in the anti-clockwise direction. What is for clockwise direction? What if for clockwise direction? So this is anti-clockwise. If it is clockwise direction, means instead of k vector, we can define it as minus sign. So here minus j, here minus k. Okay. So based on the direction, we will be saying that I am saying that force here it is experiencing a force, here it is experiencing a force, right? So after experiencing a force, which field will created here? It is a current carrying conductor, so electric field will be created over here, right? So the created electric field we will be saying that is moving inward direction. Okay, moving inward direction means we will be putting that in minus I vector. You should remember this. Okay, moving in the any electric field or magnetic field, if we are saying that it is moving inward direction, inward for a distance r, I am measuring how much the field is. Okay, for the distance r, how much the field is I am measuring. In a reticular field transfer if we are taking the capacitor, it can conduct, right? If these two conductors have to act as a parallel plate capacitor, means who has to be transferred here? Electric field should be there. Okay, so the electric field should move inwards. If it is moving inwards, means we will be taking that as in the clockwise direction. We will be denoting the I vector as minus I. Okay, so if the electric field is moving away, that is outward direction, we will be saying it as plus I vector. Okay, so inwards means minus A, clockwise. Okay, outwards means plus A. You should remember this. Okay, so after this, how many of you remember the properties of this vector quantity? What are the three properties? Did we clear this basic? What is scalar quantity? It will having magnitude or what is vector quantity? Having both magnitude and direction. After saying that, we will be discussing about what? A conductor, for example, only I have taken the Coulombs law. எதை கன்சிடர் பண்றோமோ அதனுடைய கேப். ஓகே, so next we will be discussing about what properties of vector quantity. What are the three properties? எல்லாமே படிச்சதுதான், இத ரிமைண்ட் பண்ணி பாருங்க. What are three properties? Identity. What? Curl, divergence, that is other. Okay. Other three properties. I told you that we will see another topic what? Vector algebra. Okay, for vector algebra only we are seeing this much of it. So for addition, subtraction and multiplication, what are the three properties? Now think and say. Associative. Study this. Associative property. Cumulative property. Distributive property. Okay. So the first is associative property. The next is cumulative property, and the last one is distributive. Distributive property. What is associative property then? Associative property means two conductors are there. So you have taken the first conductor as A vector, second conductor as B vector. For associative property, what it does mean? A vector, you can consider this as property. Okay, A vector plus B vector will be equal to B vector plus A vector. Mathematically, you know that. Okay, when we are adding two vectors, we can write it as A vector plus B vector is equal to B vector plus A vector. Okay, and what is cumulative property then? That is distributive. Okay, so cumulative, I will tell you. That is A vector plus B vector plus C vector is equal to, we can write it as A vector plus B vector plus C vector. This is what cumulative property. And the last one is distributive property. What is distributive property? A vector of B vector plus C vector is equal to A vector plus B vector. What it is? A vector plus C vector. A vector plus C vector. Okay, this is what distributive property. This is how we will be going for the actions of the vectors, vector quantity. Okay, these are the three vector algebra for the properties: associative properties, cumulative properties, and distributive properties. Okay, clear with it? So these are the basics. Okay, what are the quantities? Scalar quantity, and this comes under electrostatics. So we will be defining scalar quantity, vector quantity, and its difference. Can you tell me some examples for scalar quantity and for vector quantity? Okay, if it is asked as a 2-mark question, differentiate between scalar quantity and vector quantity means you have to say that scalar quantity will have only the magnitude, vector quantity will have both the magnitude as well as direction. For example, what is the example for scalar quantity? Speed. Weight, okay, mass, okay. So distance, correct, exactly right. So examples for scalar quantity we are saying that distance, speed, mass, and examples for vector quantity, force, velocity, displacement, acceleration. All this will come under with respect to, because these all will move with respect to the direction, right? So it will come under the vector quantity. Can you able to resume points? Why I am saying these examples of scalar quantity and these examples of vector quantity? Because mass is defined. Okay, that is defined. It depends on only the magnitude. ஒரே ஒரு constant value depend பண்ணிருக்குனா that magnitude first. Okay, so if the force to the core, if I give some punch, it will move according to that particular force now to the body. It will with respect to some distance. It will move with respect to some factor. There is a change that will comes under the vector quantity. Okay. Likewise, acceleration. What about acceleration? First, velocity. Define velocity. Displacement by time. So, the respect to time, it's change in displacement, right? The ratio between displacement and time depends on for whom velocity. So, it will comes under vector quantity. Okay. So, the two factors will comes under the vector quantity. Okay. And now, we are clear up to this basics. Okay. Now, Coulombs law. Write out the statement. Put on the heading as Coulombs law. And write out the statement. Coulombs law states that Coulombs law states that the force experienced by the two-point charges. The force experienced by the 2-point charges. The force experienced by 2-point charges is directly proportional to the force experienced by 2-point charges is directly proportional to the product of 2-point charges is directly proportional to the product of 2-point charges and inversely proportional to square of the distance between them and inversely proportional to the force experienced by these 2-point charges is directly proportional to product of these 2-point charges and inversely proportional to the square of the distance between them. You able to get my point? I am saying that the force experienced by 2-point charges, force experienced by the 2-point charges is directly proportional to the product of the 2-point charges Q1, Q2. We can in bracket we can write it as Q1, Q2 and inversely proportional to the square of the distance between them. Okay. And now I'm saying 2-point charges. So this take this as 1, container 1 and if we take this as 2. Okay. So the first force that is F12. This is due to the force that is exerted from the charge 2 Q2 from the second conductor due to the second conductor from the first. Okay. So we will be saying that as F12. Okay. So here the force experienced is F21. So from the statement now we can define it, right? So that is the force experienced from a unit positive charge is directly proportional to the product of the 2-point charges Q1 that is Q2 and inversely proportional to the square of the distance between them. Okay. In order to remove the proportionality constant, what we will be doing? We are going to do the proportionality constant. So that constant is K. Okay. So F is equal to K into Q1 Q2 by R square. So what is the K called? That proportionality constant and the proportionality constant is what? Already derived and it is given by the scientist. What it is? K is proportionality constant that is equal to 1 by 4 pi. K is equal to 1 by 4 pi epsilon naught. And what is epsilon naught is here? Permittivity. Epsilon naught is permittivity. And what is the constant value for it? 8.854 10 to the power minus 12. Did you remember that? It is saying one time we go through that 12. Correct. So it is 8.854 into 10 to the power into This is minus 23 and minus 12.
Minus 23.
Minus you say me. Correct. You tell me minus 23 and minus 12. 12. Once again we go through that. Correct. Correct. You are very much sure about it. Okay. Because I okay minus 12. What is the unit of it? What is the unit of it? Newton per coulomb per meter. Okay, so this is the permittivity. Okay, that is K. Overall, the constant of K, what it is? What is the value for pi? 3.14. Okay, so when I am substituting the K is equal to 4 into 3.14 into epsilon naught value, we will be getting K as 9.9 into 10 to the power. What it is? 9 into 10 to the power 9. K as 9 into 10 to the power 9. Clear? That is the proportionality. We have said that proportionality constant, right? Its value is 9 into 10 to the power 9. Okay, so that is how you have to define the Coulombs law. First, you have to get the statement. The force between the 2 points is directly proportional to the charge of the. It is the product of the 2 point charges and inversely proportional to the square of it. This is multiple times even I am saying this. So if it is in the 2-mark question, somebody of you still haven't written that. Right? Okay, remember. So Coulombs law said that the force experienced by the 2 points is directly proportional to the product of the 2 point charges and inversely proportional to the square of the distance between them. So you have to write as force F is proportional to Q1 Q2 by R square, and Q1 and Q2 is the point charges of the 2 points. Okay, R is the distance. And whenever we are removing the proportionality constant, we will be removing it with the constant K. And that K is what? 1 by 4 by epsilon naught. And that epsilon naught is what? Permittivity. It has the constant value. After substituting this constant value, we will be getting the value of K as 900 to the power. That is the constant. Okay, that is all about Coulombs law. So, when we are speaking about this force, okay, F1 to F21. Overall, we have defined the Coulombs law in terms of force F, right? For F1 2 as well as for F21. How will we defining that? That is F12 is due to the force that is being exerted from the second to the first. When you are saying F21 means the vice versa. No need to confusion. Okay. So now when you are saying this is due to the force second due to the towards the first, right? So when we say that F12, what I told for the initial vector quantity towards inwards, outwards. Okay. So two forces. So first force will be in the direction, right? So the second force will be in this direction. So these two forces, one is towards the inwards and other is towards the outwards. So when we are saying that, how will we define as F12 is equal to minus F21. Okay, F12 is equal to minus F21. What are these quantities? These are vector quantities. So we will be generating it as F vector, right? So now, when I am writing this in terms of Coulombs law, F12 vector is equal to K into Q1 Q2 divided by R square. So I am denoting it as a vector quantity means I have to put here R cap. Clear? How this formula arises? F12 is equal to F minus F21 because the force of this Q1 is towards inwards and the force of this F2 is outwards. So we can write it as this like this also. Minus F12 is equal to F21. Okay. In either cases you can write it. No need to minus 4 no both are two different opposites. So you can make the sign change accordingly. Okay. So now F12 vector is we have to add the unit vectors also. That is all about the entire Coulombs law and the comparison between the two forces in the two containers. Clear? So write on this. After that, we will be going for